שמעתי את
Yes, we
עצמי.
hear and see you well. We'll give it another 3 minutes and then we'll start.
Sure.
Hello, everyone, and welcome to the last lecture of the elective course Agentic Systems. Since this is kind of a standalone lecture, which does connect to other materials, but can also stand alone and is very cutting edge, we decided that we'll also stream this lecture on YouTube in the Nebius YouTube channel. So Serj, as you know, you are being broadcasted live. So we have quite a lot of guests. A guest on YouTube will not be able to ask questions, but guest on Zoom can ask question on the Q&A as usual. And Serj, the stage is yours.
Hi, everyone. I'm very excited to have this opportunity. This was a big privilege throughout the course, but I don't want to summarize yet. So we'll start with just in a few sentences summarizing what we had in our... Yes, I'm Serj Smorodinsky, and let's just go over on some bits of the previous lesson. So in our last session, we've went over reactive RAG, agentic RAG, I mean. And we saw different patterns of how we can use different user queries and finding the relevant information through some introspection of the LLM, basically doing transformations of queries and doing retrieval and then critiquing it in order to improve our retrieval. Then we talked a little bit of about topic discovery, and we saw agentic ways on how to basically improve the basic topic discovery pipeline of topic discovery. Now that we covered both of those topics, we can proceed to additional, more advanced subjects that are built upon the same building blocks. So this time we'll go over deep research-like features, which is basically taking agentic RAG to next level, like on steroids. So we'll go over deep research, which are basically the features that allow us to get very detailed reports. If you have used OpenAI's deep research implementation or any open source solutions like Storm by Stanford, you already understand the value of this complexity of a system. So we'll go over deep research, then we will venture into web browsing agents. So if that wasn't enough, we'll also finish with MCP. I have to say, out of those three subjects, MCP is more of a technical overview. And let's start with more of the theory behind deep research and browsing agents. Okay, so without further ado, let's start with our first presentation. Can I get a privilege to share? Permission? Carmel, I think I have permission. And I'm back.
Yes, you can share now.
Perfect. Yes, I can. Okay, here we go. Great. So here's a screenshot of OpenAI's deep research. So there's some request of a summary of the different providers of language models. Before OpenAI's ChatGPT gets into actually creating the summary, it starts with a question. So deep research has this notion that in order to create a very detailed report that is on point with the request, there might be a need to ask questions. And this pattern is somewhat simple, but it permeates um, the whole lecture, and it has very profound implications. So instead of just sending it off to some requests, now it's a matter of conversation and figure out together what is the actual goal. Well, basically, who doesn't want great research output, right? So it sounds very cool and awesome. Underneath, it's basically a lot of additional calls, additional complexity. There's not, there doesn't have to be some quantum computing behind the scenes. It's more of the things that we've already seen. So the same patterns of critiquing, of retrieving, and then requesting for feedback. So the same building blocks, basically extending test time inference and extending tokens in order to improve the output. And but why a single LLM response is not enough for a grounded report? That's a question for you for a moment. Just ponder about that. I kind of miss the interaction in the class. I know it's not the same thing, but I really love people like cutting me off and asking questions. So feel free to write whatever you want in the chat. Like I really like creating these kind of conversations and interactions during the class will improve it, I promise. So really ask away and also try to participate. Okay. So again, why is a single response not enough? So we can think about it from different lenses. Well, first of all, we know that um, creating additional calls and additional requests extends the context. And sometimes we need to have more ground for thinking. Whenever you're up to a difficult task, you're probably writing down the details and also having this internal conversation with yourself. So we want to kind of mimic that. And of course, if we want to get a detailed report, which is, oh, I have a Q&A here. And because of hallucinations. Thank you, Amir. Uh, hallucinations, they kind of happen in both mechanisms. So it's sort of a property that just exists. We can reduce them through different methodologies, but I wouldn't say hallucinations are the main cause of not doing it in a single call. It is supporting, so I agree it can help reduce, but basically there's no other way to get some feedback from the user. So deep research is these kind of features involve by default the user. Okay, so we have different implementations of deep research-like features throughout the academy and research. OpenAI wasn't the first. We had different kind of systems, and we're going to meet them. So we're going to talk about Storm and Long Agent. Here's a more deep dive into why a single call is not enough. Uh, and definitely hallucinations is one of the reasons, so we can really cross-validate. And of course, LLM training might be outdated or incomplete, and we need to have additional tools of searching things, for instance, on the interwebs. And if you really want to include like sourcing and quotes, it really helps to do it in several stages. And let's see if I didn't miss anything here. Yes, those are the most important things. So what is Storm? Storm is a system that produces well-cited articles, like Wikipedia style. It was built by Stanford, and basically they wanted to accelerate the pre-writing and research process of us. What is the abbreviation of STORM? It's synthesis of topic outlines through the retrieval and multi-perspective question asking. As I've promised, questions and answers are a theme in this lecture. So we actually, let's skip to, no, let's skip to this one. How does Storm works? It basically divides the work into two sections, the pre-writing and writing. The pre-writing stage, we are creating some kind of an outline, which then there are different Q&A tasks on top of it in order to create different perspectives. And then there's the writing part. I think you kind of already got used to multi-system agents at this point. So you can see that we are splitting tasks to different, let's say, aspects in order for each part to have its own characteristics, its own evaluation, and to gain advantage from uh, agent specialization of each task. So how does the pre-writing stage works? Basically, we try to discover diverse perspectives. Why? Whenever you're trying to write something, it is valuable to wear certain different, let's say, roles. So, one time you may be interested, if you want to write about, um, let's say, the newest news about AI. One perspective might be on the security side, another perspective might be on the innovation, and another one on how fast are solutions being internalized in different companies. So that's already like three perspectives. So it's very worthwhile to kind of segment the topic into different sections. Then the interesting part to me is the simulating conversations. So these conversations, based on each perspective, now there's some conversation of how exactly that perspective, how does it plan out to? And that Q&A, basically that this conversation is now ready to be curated into an outline. This is the final stage of the pre-writing stage, basically creating an outline that then it will be consumed by the writer agent. Any questions so far? Great. And what I like about um, the Storm paper is that they try to show the alternatives. So let's say we want to create an article by directly prompting. So you can see option A is ask 30 questions about a given topic. these questions are generated, but both basically the questions are generated, the questions that are being generated are quite simplistic. You can't really get to a deep understanding of the topic by just understanding the when, the how, and the where. Those are the basic facts. But in order to write a Wikipedia like article, we need much more than the when, the how, and the what. So B and C showcases additional complexities. Like Storm is basically B plus C. So we're first creating sort of the perspectives. So we're talking about transportation arrangements, then the budget. Basically, we are extending the topic instead of just staying on the basic grounds of understanding what, where, and the how and when. We're like creating these subtopics, and then C expands on them. So, given a certain perspective, now let's try and gather the when, the where, and the how, basically. So we can reduce it to simple questions, but only when we get the perspectives. So the main observation of this article is that in order to gain wisdom or to extend the knowledge about a certain topic, there's a lot of emphasis on highlighting the effectiveness of asking questions during information acquisition. The storm writers basically took they have thought about human psychology, the way that we kind of work and create information, and they derived a strategy for AI based on that. And that's a pattern that I love. So going from observation on how somebody does something and then making like thinking how to transform it to the AI. Great. Now let's see the whole process in one full diagram. So we're starting with the topic T. We're basically serving for different information. We're identifying different perspectives. And then we go into this loop of reading and asking, splitting the queries, searching, synthesizing, and then going into the generation, refinement, and outline. So this is the pre-writing stage. It is pretty complex. You can see a lot of thought went to the actual the pre-writing process. Okay, here's a direct quote from the paper. So the simulating conversation, it is based on the theory of question and question answering based on a different article. And what's interesting about it is that you never know where will you get to in this process. So you start with basic questions, but by asking additional ones, we basically understand that the more we ask, the less we know. You know, it's a phenomenon that you start with maybe some vague understanding, and then you understand there are much more questions to ask. And so basically, in order to kind of simulate this, you can even think of this as a sort of a search process, a dynamic search in the space of information regarding this topic. So you start with this maybe a small patch, and you kind of shoot off to different places to cover more and more land of that topic. This is a relevant video that I've seen, totally unrelated to AI, but I really loved it. It's a short one. I don't know if it is possible to hear. Oh, you can see the subtitles. People can think, not really. Most people think by talking. It's really hard to think because to think, you have to ask yourself a question. That's hard enough. To actually ask, you have to wait for the answer. Then you have to assess the answer critically, which means that you have to divide yourself up into two or three people, each of which has a different opinion and have them argue about something. So without knowing, Jordan Peterson outlined the paper of Storm basically, and he is right. It's really hard to do all of these parts simultaneously while conversing with someone. As as in my own experience, whenever I'm in meetings about deep conversations, the whiteboard really helps me do that because I have more time to process things. When everything is very verbal, I tend to really, I'll say it otherwise. The quality of my answers are raising the more time and the more whiteboard I have to answer, basically. Okay. Here's an outline in ASCII of all of the steps. I love the style. So there's this loop over perspectives. So for each perspective, we're asking questions and then we're trying to answer them with sources, with quotes, by searching the internet. Then we're aggregating all the perspectives and generate the initial outline and then refine them. We're also look at some code of this. Any questions so far? Okay. I try to kind of outline the main steps because the previous slide was kind of heavy. So we are still in the two-stage system. We have the outline generation and the article writing process. Of course, it is conditioned by the outline that is generated. Okay, now let's go over an actual example of a certain topic and what each process does and what does it bring to the table. Let's say it like that. So here's the topic: impact of climate change on polar bear populations. A very exciting topic. So we start with searching the web for different facts on the subject. The initial outline that is proposed by the system is like these 5 steps. But of course, we'll get much more deeper than that. Here's an example of the perspective guided Q&A. So these are the different perspectives. So let's say we are thinking about ecology. So in that perspective, how has the sea ice decline altered polar bear hunting grounds? So ecology is more about the environment and physiology. What biomarkers indicate nutritional stress in bears? Are they secreting additional hormones and things like that? Which subpopulations are most at risk by 2050? How are Arctic communities affected by increased bear encounters? And what mitigation strategies are being deployed internationally? So all of these are very different from one another. So we see how we kind of expand the viewpoints with the different questions and perspectives. Then we're trying to basically answer these questions through information retrieval system. So we can use the same Wikipedia that we're talking about in order to try to find answer to these questions, or use whatever other search mechanism you want. Whenever we try to answer, we should also quote, because then we'll use the quotes within the actual writing. So we can see a couple of the answers. And now we refine the outline sample. So now it's much more in depth. And there are already some facts in here, and there should be citations. Now let's go for the actual article writing. Hey, here's an excerpt from, actually, this is by Storm. Like, this whole thing was created by Storm, so it's a real artifact. And now let's just have a sneak, uh, just a sneak preview. Oh, I have question and answers. Okay, Omer, does it mean we produce text from the documents? Or in other words, do we generate text based on the documents? Yes, in a way. Similarly to how retrieval augmented generation, I'll say it otherwise. That's why the previous lesson we talked about RAG and agentic RAG. Basically, most of the time we are generating text based on facts. These facts are represented by documents that we retrieve. We can't expect the LLM to know, and we actually don't want the LLM to use its own internal knowledge that might be flawed. That's how hallucinations are creep into. So yes, we are generating text based on the retrieval, the answers that we retrieved to the documents. And the answer itself is also generated. The citations prove what were the documents that you used in order to generate this. I hope that Omer, if it answered your question, please nod. Ophir. Oh, I have a few ones, additional ones. How do you prioritize rank the questions? Which are more important than others? That's a great question. I think this framework assumes that all questions matter, but during the Q&A process, basically the LLM decides when exactly to stop it. So this stop criteria is basically something dynamic that we can try and influence. Yeah, I expect polar bears users to have at least some bias. I guess so. I guess so. If we would want to mitigate bias, we can change the prompts of the system to try and create perspectives that are um, complete. So if I would say, write me an article of whatever political issue there is, then it's very logical to try and see the same subject from different angles that might be even opposite. So I think these kind of things we can just change the prompts a little bit, tweak it, and we'll get there. That's a great question. During the perspective gathering, do you run? Yes. The web research is running throughout this whole thing. Basically, that's how we try to collect answers. That's how we create this initial outline. So we're very heavily using Serj all the time. Storm is model agnostic. Yes. You'll see in the code that I'll show in a minute that it's very interesting to see how they built it. I really love uh, going deep into the actual code because you learn a lot by looking at open source packages. So we'll see it in a minute. Is there a difference if using reasoning models? That's a great question. There is a difference. The main difference is that reasoning models, they're using planning inside the reasoning tokens. So basically, they can guide themselves as well, and they can use web search even prior to generating the response, the final response, I mean. So yes, there is a difference, but in order to effectively um, we can just keep using even the same reason models will work in this framework. It's just that they can use tools by themselves during the process as well. So it's a little bit different, but for the purpose of this lesson, we can imagine that it's kind of the same. So theoretically, it is the same. Practically, it's a little bit different. As always, that's the difference between theory and practice. Okay, so let's review the code just for a few minutes. So you can try Storm now. So it's open for anyone to use. There's also there were updates. Let's just for a moment, let's do this. Okay, so let's just write what are the latest AI innovations regarding to LLMs. And here already, I need to answer a question. Please share the motivation. I am presenting demo of this class. Experienced AI engineers. Okay, it will take a while. Let's go over the code for now. Okay, so first, we is it model agnostic? So let's prove that it is. Let's say probably it will be somewhere around here. LM. I remember there was this list. Here's already like a mentioning of Anthropic and OpenAI. And I also saw Light LLM. Yeah, so Light LLM is basically a proof that it's model agnostic because Light LLM is a framework in order to be model agnostic. Great, so that's one. Now let's try to find the actual code that the the prompts and like where is the meat. So let's go into here and there's a model for each part of the whole mechanism of the pipeline. Let's start with persona generator. So the perspectives are created for different personas. One warning, this whole article was implemented with DSPy. It's something that I was really torn about whether to introduce in this course or not. Do you hear me? Because my microphone is blinking.
Yes.
Yes, okay, great, thank you. Stop blinking. Anyhow, so I was really torn about whether to talk about DSPy. So I'll just take this chance and say like 3 sentences about it. So DSPy enables developers to outline their tasks in a very programmatic way. So basically, instead of writing a prompt, you write a structured output liked class, and DSPy can utilize that in order to derive and optimize the instructions of the actual prompt. It's a great way to kind of move from prompt engineering to prompt programming, something that I'm very into. But I didn't want to introduce that with the all additional complexities of talking about LangGraph and all of that. So if you're interested in DSPy, you can follow me on LinkedIn. I'm writing tons about it. Or just read about it by yourself. So it's great. So let's see just an example of single prompt here. Cheeky. So where is the prompt? Here it is. So here is an example of, so we won't see prompts actually because we're seeing the SPY, we'll see signatures. A signature is like a prompt, but it's like a prompt but with structured outputs. So basically we define here a topic that's the initial input of the system, and we create related topics. And that's an input field and that's an output field. This whole thing is sort of the first system prompt, like the main instruction of the goal of this task. Let me close this thing so you'll see it. I'm looking for examples that provide insights, interesting aspects. Great. Then we need to generate a persona. You need to select a group of Wikipedia editors who work together. Each of them represent a different perspective, role, or affiliation to this topic. And so what is our input? Again, the topic that we're working on. Examples, wiki page outlines of related topics for inspiration, and then personas. Then there's the, oops, what did I do? Stop. Discover different personas by researching topics, by reading Wikipedia and related topics. So now that's like a more complex structured outputs because we have a forward function here. This already for you probably have some experience with PyTorch at this point. So starts looking very PyTorch-like because DSPY is really it took PyTorch and computational graphs as inspiration. So basically, a signature or now it becomes a model, and a model has it contains all of the logic of what to do, searching for things and so forth. Maybe containing several signatures. You can see it has different tasks here. Okay, great. I think that's enough overview of the code, unless somebody has a specific question.
Can I ask a question like in voice?
Yeah.
Just a short question about the SPY. From my experience, if you give it a prompt, it doesn't change it dramatically. It's kind of tweaks around like numbers and words, but it doesn't. If, for example, if you give it 5 cents, it doesn't give you 10. It doesn't change unrecognizably your prompt. Is it something you noticed, or I'm doing just something wrong?
How are you optimizing the prompt?
Basically, optimizing. There was a task about readability, improving the readability of the task. I gave it a formula to improve readability that counts number of letters, a number of words per sentence. So upon this formula, it needs to improve the prompt. But when I looked at the history of what he was doing, how it was changing, in the end, I was getting different prompt, but it's not like unrecognizably different. I still see parts of structure of the prompt. I was wondering, is this is how it works, or it can generate it like completely new prompt from what you gave it? From your experience, I don't know.
Oh, that's a great question. I'll outline a little more about how the SPY works. So basically, you can view this thing as the initial instruction, and then during optimization process, this instruction can change. You can add additional maybe descriptions or whatnot. It's all dependent on what goes through the optimization process. In order to optimize, you need some kind of ground truth. So the optimization drives itself by optimizing the accuracy on the examples of the ground truth that you gave it. So one thing that might have happened is that even without much optimization, because there's some random chances here, it starts with basically the basic stuff that you gave it. If that's already hitting the optimization mark, that might be the best result. So it's really dependent on the optimization process. It won't change things, or the prompt won't be changed a lot if it won't be, if that wouldn't drive a better result during the optimization process. Is that answer clear?
Yeah. Another thing, small, if I may. I was digging into the code. I haven't found what do they actually use, techniques they use to improve this prompt, and how is difference, for example, asking the LLM, here's the prompt, make it better. Do they use few shot? Do they use some kind of a techniques? But what's the engine of the SPY?
There are several optimizers. That depends on the optimizer you use. So there's an optimizer for the instructions. There are several ones, the MiPro and Capro, if I remember that well. You can kind of the most simplest version of that, which is not exactly that's what's going on, but I think it can explain it itself. Yes, is doing another LLM call of take this prompt, change it a little bit, and then test it on the examples you gave as ground truth. So in order to optimize something, you need to have a proper evaluation. You won't be able to optimize things if you don't give it some examples to test whether the prompt was changed for the better. So one way is to ask LLMs to create better instructions. That's one, and the other one is playing with the few shot. So you can give it tons of examples, and it will find examples that optimize the goal that you give it, that optimize the evaluation set, basically. So that's the instructions and few shot, just as you kind of guessed. But I don't want to derail to have this whole lecture about the SPY. Feel free to talk to me afterwards. I'll happily answer all the other questions.
Thank you.
Sure. Okay. At your free time, I really, really recommend going over the libraries that I'm showing you during the lectures. Okay, so that's not it. That's it. That was the SPY. But now there's LangGraph. Because we already went over LangGraph, I wanted to show you how does a LangGraph like solution would look like. This is by the official LangChain repository. So you can see there are two versions of this. There's a workflow version, and there's a multi-agent version. The multi-agent version is probably more dynamic. I just want to make sure. Yes. Okay, so just a quick peek at how does it look like. I want to look at the prompts. That's one of the most interesting things. So let's view the multi-agent. And let's see the implementation. So we have different states here. So that's a more complex system than we saw at our examples, and that's okay. There's also MCP thing under the hood, which is interesting. We'll talk about MCP in another two presentations at the end of the lesson. Get supervisor tools, get research tools. What are research tools? Get search tools. Okay, great. So we're using here two different search tools. The Tavili. I love it that it's called Tavili. In Hebrew, it's brain me. And there's DuckDuckGo. So they're extending the tools with these search tools. We're going to use them. And let's see the actual graph. How do we create the graph here? Supervisor tools, bind, research agents. Here's the actual invocation. Okay, so init chat model. And then we bind the messages and we initialize it here. Who's gonna call this? Here's my graph. That's what I was looking for. Okay, so we have the research agents, then we have a tools node, as we've seen in the examples in the previous class. We're having an additional conditional edge. So the research agent decides whether to continue or not. And then it has an edge to the tools as well. And then the supervisor workflow. You can see that basically we have two graphs here. Like a graph and a subgraph. And both of them get a different state class. So here's an example of a more complex setting for LangGraph, which might be helpful for your next homework, which is basically to re-implement the data analyst as a LangGraph component. We'll talk about it later about the new homework, but I'm already setting the stage for this new task. Here are the prompts. They use this this pattern of saving all of the prompts in one file, which is fine. So you can view the different prompts here and take maybe some inspiration for whatever you're doing. Here's a final example of a more simple LangGraph example. You can see everything can be like it is a spectrum on complexity. So I found this implementation by Yash Agrawal that had a more humble, basically, implementation with one state, and we have the query planner, should refine. We have like this critique option. That's an interesting thing to look. It does a lot of things. It takes the search queries. It checks how many times it already been in this node because it has a stopping criteria. Here you can see max query refinements. And then basically it calls an LLM in which that is the input to. So you have another implementation. I won't go the final one. Great. Any questions so far? Okay. Here's a short summary. So basically, Storm is basically the main idea here is that in order to create a very detailed report, it should include this iterative Q&A. In order to expand whatever you're working on, you need to add additional topics. And one of the ways to add additional topics is by asking what is relevant, what is less relevant, and wearing different perspectives. Storm is also a great example of a multi-agent system. It's far from being one prompt, right? Because we have broken this task into so many subtasks, we have the chance to evaluate each subtask on its own, which has a lot of value in complex systems. So they're kind of decoupled. You can test how well you're creating different personas. You can test how well you're creating the final outline. You can try and test. The evaluation part of this is actually quite tricky. Just think to yourself, how to judge whether an outline is a good outline. So with these generation tasks, one of the hardest things is not to actually run it, but is to figure out how to evaluate it and to like utilize whatever trick you have in order to have something that you can trust. And here's a final question, a rhetorical one. Is it a workflow or is it agentic? Where is it on the spectrum? If somebody wants to answer that, you're free to go. Okay, so I'll answer. It's both. You can implement it as a workflow, meaning that everything is pre-planned. You can decide how many refining steps you want. You can decide how many times you want to search something. And basically, that's what you've seen with the latest implementation. It can also be fully agentic. On each step, we can have as many critique steps we want. We can have as much feedback as we want. We can try and create new tasks. But it is still within a single task perspective. So this is still not as if you're creating code that you're going outside of the box. Like the tasks are pretty well defined. So it's not fully agentic anyhow, in my view. Basically, it is still confined within a single task. So 3 out of 5 on the agentic spectrum here. I'm joking. Okay, we have another option on creating deep reports. Imagine that you have a full book, and the question is how the characters are developing, what is their development arc throughout the story? How would you implement it? That's not a simple task. Like a book has dozens of pages, there's a lot of chapters. There should be like some segmentation of the task as well. We're already familiar with like divide and conquer strategies. So long agent, it does exactly that because the paper is from 2023, I think, and there were models with huge context, maybe up to one. There was one model, maybe Jamba by AI 21 with 1 million tokens context, I think. But even if there wasn't, there's a lot of evidence that you still probably should divide and conquer the state and not just ask it in one go. So here's another view on creating like collaboration in a multi-agent system. This is from the original paper. I love the visualizations of like 8-bit style stuff. So there's a leader. It creates like ton of workers, basically a worker per chunk. And the members also they're responsible of generating answers based on different questions. So it's somewhat similar to Storm, similar idea. So in step one, we construct a team based on the description of the task. In the second and the third step, we gather information from all of those uh, chunks. And then in the third and the fourth steps, we are trying to kind of summarize all the stuff that we have so far, and we're trying to see whether we can deduce the answer. An interesting part is resolving conflicts. So if we see that similar questions get different answers, we need to resolve that conflict and decide who is correct and who is not, which basically is a great step to mitigate hallucinations as well. So if I see some consistent answer and then there's just something odd there, then in this step we'll hopefully we'll be able to just remove that misleading answer. Here are all the steps in ASCII. Just look at it for a moment. Two things that I haven't mentioned so far is that the chunks are being split with overlap, which is like a default setting for RAG. And then another thing that I've missed is that we also check whether we have any missing information. If we do have a missing information, we go and get it. Here are the steps in a more high-level stages. We generate sub-questions. Each sub-question gets a team member. Then we're answering per chunk. We aggregate the answers. We're critiquing. Basically, these steps, conflict or missing info, is what I call, and others call as well, critique. And then we answer if we have enough information. Any questions so far?
Any comments about the temperature or recommendation?
Because we're basically talking about facts, the goal of both deep research and long agent is try to answer something based on facts. It's not creative writing. It's not as if you need to write a novel story about a dog flying to the moon. So as long as I'm in the setting of trying to be factual, I'll use zero temperature. Whenever I'll try to create something new or novel, I would raise the temperature. So that's my intuition. Sure. Here's an example from their paper. They've listed like, I think 10 examples. It's pretty fun to see how the prompts change with time. So here's the task objective. It's a factual question about population. Generate instruction for members. Now we need to generate instruction for, you can ask them to answer a certain question. And we create different questions. So here's a question that was generated. And then we see the output. And all of the members try to answer, except for the members who refuse to answer. We have these clusters of answers, so we can see like some kind of aggregation. I think this UUID probably leads us to some information. It's kind of odd though. And then eventually there's some response by this member and an aggregation. And now it needs to determine if it has enough information based on this response and this response, and it probably does have enough information. So what's the emphasis within long agent? It's again creating different sub-questions and then segmenting the information into chunks due to a very large size of a corpus. So I really love their graphics. They're very 8-bit and nerdy, and I love it. The long agent scales LLMs to what now doesn't seem like a lot, but for that time period, it was really, really, really long. It splits tasks and have a specialized agent models that share and define context. It has a dynamic memory, basically. You can see the UUID that it used there. It was basically pointing to memory. It handles ultra long documents in one pass. And it's we do want to replicate this paper. It doesn't have a lot of examples. I haven't found even one actually implementing this thing. So we have an opportunity to implement it in the course and on homework later on. Okay, so basically we have reviewed two different articles on deep research like features. Both of them had similar, like some similarities. They are multi-agentic, multi-agent systems with specialized parts. That's like another theme that we go throughout the course, that um, what articles and what innovation do we bring in these lectures is not so much of like quantum-like algorithms or creating faster search algorithms between like below log n and things like that. Oh, log n. Anyhow, the innovation is in the composition and specialization of the different tasks and the way that we kind of refine and iterate the task in different loops, whether it is up to a certain step or to a certain condition. That's about it for this part. I don't know if in this setting we have some like recesses, but this is a great opportunity to take a 5 minutes for a moment.
No recess, I think. I think we can go right forward.
Okay, going forward to the next subject. As you're back from commercials, let's continue to browser agents. Now, this will be a little bit
Serj,
different. Sorry?
you forgot to show us storm results.
The storm result, no, I went over them.
No.
Oh, and what we had in the browser.
Yes.
That's a great point. Here it is. Let's see. Recent innovations, large language models. NLP, yeah, LMP is definitely relevant. Novel architectural designs. This is still blabbery. Okay, Transformer Excel, that's like 2022, I think. Sparse transformers. GPT-3. I see its material is not, it used some outdated stuff, as we see, but it has citations, which is great. But it is a very well put. I mean, like it's structured very well with a lot of quotations, citations, and the different aspects. You can see future directions. There's this bias and fairness. So there's a lot of different perspectives. I haven't even asked on challenges and ethical considerations, but they're here, right? Because it's really a lot of a lot of what is being discussed is the environmental effects of deep learning and LLMs. So this is an important perspective. And now we have an opportunity to rate the feedback. Here you go. So this, now that we kind of got used to very detailed outputs, when it went out, it blew my mind. Really. We were at the computer at work. me and the whole team at Loris.ai, and we looked at it and we were like, oh my God, it's how did it get so detailed? And we went over the paper, we looked at the code. It's really, we shouldn't take it for granted. And these kind of methodologies are implemented in Google's solution, in Anthropic's, in deep research by OpenAI, of course, as the main innovators. So it's really cool to see practical stuff by the leading labs, including their code. So this was really groundbreaking when it went out. Kudos to Sanford. Okay, thank you for reminding me that I missed this.
Gregory.
Wait just a second. Okay. From automation scripts to agents. So we're gonna first understand the domain of automating browser actions. Different use cases, what kind of browser internals we need to support it, and some challenges. Challenges with the methodologies prior to agents. Then we actually will go into how to implement and what are kind of solutions exist. First theory, and then we'll see practical solutions. We'll be able to run some code on my computer and to view some scripts. Great, let's go. First of all, let's understand the scope and motivation. Browsers and basically the internet have become a universal interface. There are millions of websites, if not billions, and everything nowadays is web-based. Apps sometimes are actually websites, like mobile apps. There are a lot of them that are implemented as a website. And of course, through automation unlocks testing, assistance, integration, and scraping, but also decision-making in dynamic UIs. So the second one, automation, some automation already exists. If you're in the field of QA, you might have already used Selenium or other like tools that maybe more programmatical like Puppeteer and others, or also recording clicks in order to redo them. So some stuff already exists, of course, in the domain. But how do we go from scripting to dynamic decision making? Yes, just because I love memes, I had to introduce some. Uh, so here's a fun joke at Internet Explorer, who's not Internet Explorer no more. Now it's called Edge. So the main innovation, how did we go from scripting to actual agents ordering tickets for movies and stuff like that? Um, a lot of the innovation is based on vision language models. As you'll see progressively in this lecture, it is possible to act without knowing what's in front of you visually. It is possible. Similarly to like people without vision, they manage around the world. But of course, vision is a great sensory tool to try to achieve your goals. So what are kind of use cases for agentic browser agents? We can automate routine tasks such as filling forms, checking reports, answering emails, by the way, as well, and some multi-step flows that are much harder, by the way. One of the things that we'll see is that browser agents introduce a lot of calculation. Like if our data analyst example maybe runs 3, 4 tools, sorry, in order to achieve something in the browser, you maybe need like 30, 40 clicks and writing stuff, filling forms. So um, browser agents have a very long history, and that poses challenges. And there's also web integration use cases, interacting with dynamic dashboards, and this is less based on UI. It's very focused on DOM, um, the internal DOM of the website, the internal structure of the actual HTML, uh, which is also very relevant. So what is a browser? Before we step into automating browser actions, we need to first make sure that we all align on the different components of websites. Basically, the raison d'être of a browser is to interpret and render web content. That's a given. It turns code into interactive pages. But how? So basically, we have a three-step or an infinite loop in a way, because JavaScript runs its own event loop. But before that, there's HTML. When the web was born, there was only HTML and sites were looking funny. I love that look. Everything was static and boring in a way, but also exciting at the same time because everybody can do it. Then there was CSS. So if HTML is a structure, so let's say we have a paragraph and maybe a headline, CSS states how exactly that headline, its font, its size, its color, the style. And JavaScript is the behavior, which you can add behavior to HTML as well, like button clicking with links, but JavaScript can add interactivity and also dynamic stuff. So it's based on, um, I'll say it otherwise. JavaScript enables you to do things that you just couldn't do with HTML. It's not all dependent on the server side, so JavaScript basically runs on the client side, and that's what's behind the complexity that we see in Facebook, Gmail, whatever you're using. How do websites are rendered? This is a very simplistic intro, but still, I think it's an important one. So we parse the HTML in order to create the DOM tree. The DOM tree is basically a tree with all of the structure in it. Then we apply the CSS and then we run the JavaScript. Great. What do we have without agents? So we already, I've mentioned Selenium, Puppeteer, there's also Playwright. We can basically create scripts in order to achieve certain goals. These scripts contain different HTML, DOM objects. Basically, we can check whatever it's written there. We can simulate clicks. So all of that is possible already without any agentic framework. If something is scripted, I can totally do it. The issue is that these scripts are very brittle. Imagine that you have written this script of automating, let's say, clicking a certain button on a web page. Now, the ID of the button might change, or it's CSS. Maybe you try to select that button via CSS property, or maybe by checking some content. Websites change and they're complex. Sometimes things are hidden or they have different properties. So writing scripts for websites that change basically is hell. They change a lot and you need to change the script as well. LLMs, on the other hand, are dynamic, and that's one of the advantages that we don't have to pinpoint exactly on what you're trying to do. You can have a goal of clicking the submit button. And if the submit button has a different content, let's say different text, it might be submit with a typo, with a Y, you might be still the LLM will figure out how to click it still, because it will look at the DOM and will understand, oh, submit is actually submit with a Y is actually submit with an I. Let's click that thing. That's the one of the main advantages of an LLM. How would a script like that, just a general script of doing something with a web page, how it would look like? So I've added this example. It uses Playwright, and we're launching an actual browser here, but it's launched in a headless state. It shouldn't frighten you much, but talking about browsers, there's a headful and they're headless. Headful is meaning that we launch the browser as it is, as a human being would do, and you see the UI and everything. Headless state is meaning that we're launching in the background and we don't render the UI. So this script is basically launching it in a headless state, which makes things faster. You don't render the UI, it launches immediately in the background. Then we go to DuckDuckGo, we'll fill in the search box, we click on submit, and this actually works. Do I have time to demo this? Let's see. No, I don't have much time. Okay, so basically you can copy this and I'll add the script to the classroom so you'll be able to run this as well. So let's say we want to test an e-commerce checkout flow. We need to search for a product, we need to add it to the cart, fill checkout form, and confirm the order. So we could have used Playwright for all of the steps because I can see, I know which product I want to check out. I know what the functionality, what kind of button I need to click to add it to the cart. And then I know in the page, because I see the source code of the page, I can see what I need to do to confirm the order. So we could have used Playwright, but as I've mentioned, and we just can't use Playwright with anything that is adaptive or dynamic. So if there's a static website, go for a Playwright, it will work. If it is complex, if it has a behavior that is dependent on JavaScript, if things are sometimes hidden or not being rendered based on functionality, then you probably need an agentic flow. So it helps us on whenever there's a need for adaptive behavior, goal-based actions. What is a goal-based action? Here I can search once for product A, product B, and product C. I don't have to define in the code what kind of product type I want. Basically, the LLM will be able to handle any product, hopefully. So it's a goal-based action. Um, it can work with variant page structure content because the websites are pretty complex. Sometimes, dependent on the view, things can be hidden if you're clicking different stuff. So the DOM changes as well, the screenshots will change. So dynamic behavior really obfuscates, occludes stuff when you need to run scripts. And if you want a realistic user simulation, basically you can try and simulate actually what the agentic flow is doing. You can see all the actions, so you get a pretty cool simulation. So why not both, basically? So we can use Playwright for whenever we want to actually change something, when we want to act on the browser, and we'll let the LLM agent to interpret the goals, adapt to the page structure, to whatever it's in the front right now, and reason over the next actions. That's the goal of basically this course. We are working with agentic systems. And that's exactly how OpenAI's operator and browser use and other frameworks work. Browser use is an open source framework that I've added to this lecture, so we'll reference that a lot. We'll see its code as well. Any questions so far? Okay. I kind of mentioned headless versus headful. So here's a headful browser. Basically, you open it as is. And we can use agentic flows for both states. But the headful state is mostly applicable to whenever we want to work as the client would, as a user would, because you see the whole thing. So operator, for instance, is working in a headful environment because operators' goal is to help us, the users, to achieve our goals looking at the screen, basically, simulating whatever you would do. So it's finding airplane tickets, it's maybe looking for groceries and stuff like that. So these kind of things are more adequate with a headful state. Now the headless browser, that's for the hackers. I'm joking. You don't operate in a graphical user face. That's how you can automate certain things that are maybe not dependent on views. And it's mostly used for scraping and automating tests. Okay, there's a question. Web searching and scraping, is it the same thing? Not exactly. Web searching is the act, I'll say it always. Web searching can be done in two different ways. It can happen in a headful state, just like I would open something and I've inputted the form, I entered some text. So that's a headful state. But it can also happen in a headless state because we can find, oh wait, it was in the chat. We can find in the DOM, you know what, I'll show it in here. So let's inspect. So here is the HTML component of this input. So I could have programmatically tried to use it and search for something. Yeah, I could have even done it through the console. So you can run JavaScript here. Oops. You can run JavaScript here and all the other niceties. Here it is. So web searching can be done headless and headful. Scraping also can be done in two ways. So it can happen behind the scenes. You open programmatically a web page, and then what you get back is an HTML response. So you can see all of the components. Because it's not being rendered, some functionality might not happen. So when you actually browse the page, there might be something else that's going on that loads additional stuff, additional components. So you can do scraping when you're headful. You can open an actual browser and kind of copy whatever you see in there to somewhere else. And you can also operate it behind the scenes in a headless state. If you're trying to look for very simple things that are always there, like Wikipedia stuff, which are not that dynamic, most of the content is already there when you load the page, you can do it headless. If it is really dependent, let's say if it's Facebook and you want to scrape some friend of yours, hopefully not, you probably need to do it in a headful state because there's a lot of different things that you need to click, different things need to load. So I hope I answered your question. Both can be done headless or headful. and they are very different from one another. The output of web searching is basically search results. It can be just information, it can be links, it can be both. And the output of scraping, it can be actually just text content of whatever you're looking for. Let's say a Wikipedia article, but it can be also just all of the tags in between or whatever you're looking for. So it's really dependent on the use case. I hope it made sense. What about LangChain wrapper of Selenium? Is there a difference? Maybe scraping using LangChain. That's totally valid. Um, most of the things that we're talking about and I'm showing can be done in multiple ways. You can use LangChain, you can use LangGraph, you can use open source tools just made for this use case. So it's really up to you. And Selenium, yeah, Selenium is great. I don't have any opinion on that. I didn't do a lot of scraping myself, so it's hard for me to say what would you prefer. Like from what I'm seeing, there's a lot of action. There's a lot of use cases with Playwright and Puppeteer. Those are the more modern tools from what it seems to me. Selenium it might be somewhat dated, but I might be totally wrong here. Okay, just to summarize headful versus headless. So tasks that are heavy in UI work better with headful agents because basically we need to render the GUI to get some information. And if it's headful, probably we don't need only the DOM, we also need to take screenshots. Headless tasks don't rely on UI and they work better with headless. Why better? Because it is faster and it has less information. When you load something headless, you might get less results and it's more contained. And those tasks are probably less tied to user sessions or UI state. So what kind of browser automation agents are there? Let's go back to the slideshow. Okay. Let's move this to here. Sorry. Yes, so there were initial tools already at 2023. AutoGPT, it started headless, but can be run headful. I think at the start of the automation industry, or at least for scraping, the headless state was really it was the default state, basically. And then 2 years later, Operator launched. It's one of the state-of-the-art tools to use it. I didn't have the chance actually, but I will probably in a few days. I did use browser use, so we'll talk a lot about that. And its default is headful. Not only default, it's the only state it has because basically it um, tries to be a competitor with Operator. So the new agentic browser use cases are much more helpful than headless because that's how people operate. If you want to automate human tasks, we probably need to view the actual browser as a human would do. I've already shown you this view of the like the inspector, and that's very useful. There's also different APIs that you can use. There are different element attributes. There's the DOM, of course, and DevTools protocol. So basically, you can control different parts of the page and screenshots. Screenshots are very important to their visual cue that is necessary for certain things. And we can also monitor the network events, which might be useful for some use cases.
Serj, can I ask a quick question?
Of
Like,
course.
I believe there are many use cases. We want to use some agent browsers to do some stuff, but I believe that most of the things that we just cover, you can do with the basic uh, code that people used to do up until now. I mean, where is the aging part take place here? Maybe I missed that.
We didn't get to it yet.
Okay.
So
Yeah.
far, I'm setting the stage of
s-
what
s-
is possible, like what can the
So
agent
we
view.
are talking about retrieving data right now, right? And then the agent part is coming after that, I believe. Um,
Yes, I'm just showing all of the internals that later will be used for the agent and what is possible without agents as well, which is really important to understand.
okay.
Can I offer to share some like real world use case for this? Maybe this would help, Omer.
Go for it.
Okay, so just as an example, my name is Nadav Mayani. I'm a PA for the course, and I work actually in the cybersecurity domain. And we often find ourselves looking to automate some scraping action against some website as part of like our engagement. And most big companies update their code like 20 times or even more a day, like if they have good CI/CD. This means that maybe you have like a static script that is working right now. That's a great POC. But like by the end of the day, it might be already broken and irrelevant. Having some agent deciding where to find the new button, like where did it move and stuff, could be very helpful. This is just like one example for why you might care about automating these things and not relying on static tools. If I understood your question correctly.
Yeah, I totally, you're totally right, on point because we also do some stuff at work that related to that. But I ask that because most of the time when you try to just scrape or maybe ask an agent to go to a specific website, read the text, and retrieve something from that, um, then uh, you don't really get good answers. And what we found out that you want to scrape it before send batches with some overlap and then get even better data. Um, but yeah, I guess it's all the way leads to that, right? So right now, if we still scraping the data, we still didn't do anything with that. I just thought there is a better way to do that. Or just, I don't know, website that you log in and then you need to press a button and then you get stuck.
That's one of the biggest limitations of the checks whether you're a robot and stuff like that. That blocks tons of agents. So I think things will be more clear. Just we can view this example. So this is from browser use website. They're including several examples of how people are using this. So you can see the user request is find flights on kayak.com from Zurich to Beijing. And on the right side, these are the actions of the agent. You can view some of the input, some of the output, the way that it views the world, its goals, its thoughts. And as I've promised, it's not like 2, 3 steps. There are a lot of steps going on here. You already, like, you kind of see a glimpse of bounding boxes. That's part of the solution. And there will be later examples, of course, to kind of extend on what is possible. I do have to say, just as some of you mentioned, the accuracy of browser agents is fairly low. It's a very complex input. The web environment is very chaotic, and the accuracy is not that high. And you'll see benchmarks later down the road. And it's interesting to hear that some of the strategies for to deal with it is again chunking. So the patterns to improve agents kind of cross between domains. So even if I need to work with websites where the DOM might be my input, still chunking can really help me figure out to cut it into different chunks. Okay, thank you for that question. Here's an example from my local machine of using browser use, the same tool that I've shown you here, just from my terminal. I'm in love with this kind of terminal, so it makes my geeky side really joyous. So you can run it from your terminal, ask it, like I asked it to query Donald Trump biography and career details, something like that. And it started going off, and it did 33 steps. So something with its decision making didn't went well, I think, because you don't have to do so many steps, I think. But I might be wrong here. So you can run it from the terminal. And there's also programmatic ways to use it. But now let's talk about the architecture of the actual vision language model that's operating behind the scenes. So the basic architecture has like 3 blocks and actions. There's the request. Then we need to start probably opening some website. We're taking a screenshot. We're taking the DOM output, like the HTML structure. And then we need to decide what to do. What does it mean, decide what to do? We'll talk about in a few slides what are the actions that are exposed to our agents. Then we need to perceive the output of whatever happened after my action and repeat. This is again a reactive pattern. So this can be done as well with planning, with pre-planning, without planning. We can do dynamically whatever we want. But in a very dynamic environment, it is much more, let's say, reactive than a pre-planning mode. Sometimes most of the times when you click something, you're not sure what you're gonna get. So you have to retake the decision process based on what you're gonna get. And then probably replan and maybe do something else. So the complexity of these systems tends to be closer to coding agents. Coding agents are very active, very dynamic. Browser agents are very similar in that regards. Like workflows probably won't do here. So it's more agentic on the spectrum. Some low-level blocks. And there are different components here. And depending on the implementation, some of them can be merged. For instance, there's always the LLM planner or the VLM planner. We'll talk about the differences. And then there's the action executor and the browser UI, the web driver. Sometimes it's the same component, sometimes it's not. Sometimes there's a different components for a visual interpretation, whatever you have there. Sometimes it's just the visual language model um, does the same role. So this is more of a functionality breakdown rather on real components. So we need to plan stuff, we need to execute actions, we need to interpret visually whatever is in front of us, and there is memory context, which is very, very important. Because tasks are highly multitasked, multi-step, I mean, uh, the way that we manage the history is sometimes more complex than just keeping it straight. Sometimes we need to cut it off, sometimes we need to summarize it, sometimes we need to offload it to somewhere else. And there's another potential complexity is that there might be a human in the loop interface. So imagine that you're asking an assistant to buy you some tickets, but you want to have this feedback of, well, just a second before you order, I want to confirm that it's okay. So this step also adds some complexity. So, and you can do it on autopilot mode, and of course you can do it with human in the loop. This is again very similar to decision points with coding agents. They're very multitasked as well. There's might be a human in the loop. So I draw a lot of analogies between the two tasks. What is the planner doing? So I won't surprise you a lot. You kind of seen examples of that. You implemented one even. We're taking the user objective and the browser current state, which is whatever is in front currently. Why currently? Because things change. So whatever we have in front of us currently, and we output basically commands. And we have two different command types. I can have a high level goal output, let's say click the login button, and then I'll have another component to figure out like what does it mean to actually do that on the screen. Or I can directly output the actual playwright command that I need to trigger. So there are two different ways to implement this, different on the dependent on the how did we implement it. Do we have a separation between another component that outputs the details of where exactly it happens on the screen, or do we output it directly? We'll see at the end of the lecture an example of an architecture that has this separation. The VLM can decide clicking on a button with some text, and that's an input to a localizer that then outputs the actual coordinates of the click. So there are actually two objectives here that can be independent, or not independent, but they have different components. They're not independent, actually. The commands are used directly to achieve the goal, of course. Then there's the browser UI interface, the web driver. The web driver acts as your eyes and hands. Basically, it's whatever you see and whatever you want to act upon. It can be playwright. It's whatever thing that executes the actual command. So if you want to click on a button with some coordinates, the LLM cannot actually do it by itself. Of course, it only generates some text that can be interpreted into commands. So the command needs to be executed within the context of something, and that something is mostly Playwright or different web drivers. Did I have any question? Okay, great. After every action step the web agent performs, the agent needs to get yes. We need to get the DOM updates based on each action. Yes, there can be a diff check. That's a great way to implement the difference. So yes to both. Actually, that's again an analogy to coding agents. Whenever you add some code, a good way to represent the change is looking just at the diff. So again, the analogy is sticky. Then we have the visual interpreter. It can be a different model that takes input, its input is the screenshot and the DOM, and it understands whatever is in front of whatever is visual in that space. It also mentions the text. The DOM contains all of the text on the page that is currently showing as well. This component, if it exists, it can output a more logical state of the web page. It can be a minified version. It can be something much more clear with sections. So there can be a lot of customization on what the output of this mechanism works like, but its output goes straight back to the loop of the reasoning. And there's the memory and context manager. Because we're in a complex environment that introduces multiple steps, we have to have some additional behavior on how to have this state. It can be simple as just a log, but of course it can be as complex as storing all of the history as a separate DB vector that you can then search and retrieve upon. So there's a lot of spectrum of complexity here. Like there is a big gap between just keeping it as it is and creating an additional DB vector and storing things there. And whenever you store something, actually it becomes a long memory. It becomes persistent. So you can also try and forget things. That's another mechanism. For us, it's pretty intuitive because we're always keep forgetting things and remembering. But with LLMs and all of that, you need to actually bake that in. Of course, there's a physical limitation of the context, but still, the memory is a very interesting function that is quite similar to humans in that sense. And then there's the main loop. And it goes as you've imagined. There's this planning stage. The planning stage results in an action or a series of actions. And then there's the action execution, which is done by the WebDriver. Then we need to understand how things change, a new observation, meaning taking a new screenshot, and taking again the DOM or the diff of the DOM, and continuing the loop. Now, the continuation of the loop can be also done in different ways. I can have a number of maximum steps to have, or I can have another module that checks whether we reach the final decision, the final answer that we needed. Or it can be also done in the planning stage. So it depends on how do you want to scope the solution. So what are the agent's tools? I blabbered enough. Let's see if somebody got the right direction. You can answer in the chat, you can answer just in here.
Web search.
That's one, yes. Opening up pages, searching on forums. What else?
Reading files.
Those currently you're mentioning things that are not that browser specific. Can you think of the browser specific tools? It's an open question to everyone. Oh, yeah, I have an answer here. The visual interpreter is a component. It can be seen as a tool, but I'm talking about like if you would now implement it. You have seen the presentation so far. If you had to implement it from scratch, what kind of tools would you give the LLM? What kind of actions can it act on the browser? We've seen examples of that with browser use case. The actions of the agent are whatever a human can do on a page, actually. So clicking on stuff. Let's see if we have an explicit example here. No, it's later. So the actions are whatever a human can do on a page. So you can give it a click. You can click stuff. You can enter text in some input fields. You can open a new web page. So whatever is possible on the web page, we are breaking the different things we can do into different actions. Yes, finding buttons, clicking, taking screenshots. These are the kind of tools that we expose to our agents. And we can show it explicitly. I have a slide with here. Because I've seen like there's some hesitation about it, I really want to double down on what are the tools. So here's an explicit list of tools within Serj. It's one of the newest implementations of web agents. It actually doesn't use a DOM as an input. It uses only the screenshots. Still, what actions are exposed to the agent? Answer. Answer is the final tool. When you implemented the data analyst, some of you implemented an answer as explicit tool, some of you did not. Here you can see that it's an explicit action. And then there's a new module, a different module that validates whether the answer is correct or no. If it is not correct, it's actually saved as another thing in the log, and we keep iterating. There's refresh, there's write, and there's click. So not a lot of actions, by the way. But these are the actions that mimic whatever you can do on a page. Those are pretty much high level. And did I receive a new thing? No. And what's nice about it is that we have another module which called the localizer that it knows how to fill the actual coordinates or whatever you want to write. So the policy is a very it's very used term in machine learning, deep learning. Policies are something that's with reinforcement learning um, relation to. So policies in this sense, to simplify, is just choosing an action. So that's the goal of the visual language model, is basically taking these actions, and whenever I need to do any specific thing on the screen, because all of these things are not specific to any component. Basically, go to URL does not depend on a section. It's just something you can do. But whenever you need to do something specific on a screen, the localizer will help fill in the details that are missing. And then these actions are actually done via the playwright or a different web driver, as we call it. Any questions so far? Great. Okay, going back. Okay, I've mentioned visual language models, so now it's the time to introduce them. Basically, we have consolidated several components here, like the visual interpreter, into multimodal LLM. So it has vision plus planning. And then we have the loop, the same loop of basically planning, observation, and so forth. Here is a great screenshot to just give you some intuition about how what is the input and output of visual language models. Most of the models output just text. The input is both a text and an image. Most visual language models output only text. Some of them, text-to-image models, also can output different manipulations on an image. So here's an example. Is one cat behind another? Yes, one cat is behind the other. So text and image in, text out. Zero-shot segmentation. Segment striped cat. And for this input text and image, the output is another image. So we won't be covering these kind of models. We are talking about vision language models that output only text, or as we are using them, we're mostly using them as planners for actions. So they actually output mostly actions with reasoning. A little bit about how it does it work behind the scenes, because I couldn't help myself. So basically, we need to somehow have information, dense information about text and the input image. We can view it as two different, let's say, embeddings or vectors that are then transformed to the same space, which the decoder, we have a text decoder at the end because we are generating text. So that's its input, both the visual and language information, but it's projected in one space. So it's not really two different inputs. It can be, sometimes they can be concatenated. I don't want to go into these details. It's kind of out of scope. And I see there's new questions. Clip, yes, clip is next slide. So I'm gonna talk it in that context. Okay, what are the pros of VM AI agent given the low accuracy and protection of site from AI agent? Maybe it's heading towards automation remain only for cases where API access is possible. I think it's somewhat soon to understand where we're headed or whether the accuracy really limits the functionality. It is now, like, yes, the accuracy is low right now, but I don't know what's gonna happen in another year. Just as GPT-3 didn't create that much of impressive text, or it did, depends on how you view it. Like GPT-4 kind of did. So it all depends on specific tasks. I don't think that we are hitting the limits yet. There's much more to innovate in that front. And API, yeah, API access is great for certain tasks, but whenever you need to act on visual data on websites, clicking on stuff, there needs to be something that needs to interpret the GUI environment. And that's much of wider scope than web browser agents. Web browser is just one type of GUI agents, as I view it. Like computer, there are different agents that can actually operate on your computer as well. Computer use agents. These type of agents need to work with visual information and to decipher it. So it's even broader scope than web browsers. How do we train this kind of dual information, dual modalities models? One of the ways is to use contrasting learning. That's a very robust way to train language and images by using tons of information because it uses contrastive learning. You don't need uh, a lot of human labeled information. There's a lot of information that can be already utilized, like pictures with their descriptions that already line around that you can pick up. And then what's important is that description of images that are close to one another, the descriptions should be similar as well. Also, images that are similar to one another, their embedding should be closer as well. So there's this game of minimizing the distance between similar things and maximizing distance of different things. And this can be done on a very large scale. So that's CLIP. What's really what I find interesting is it's sort of a breakthrough beyond web browsing. clip was a step towards making visual models, deep learning based models, more general. Why is that? Because if you train the computer vision based like object detector that detects two types of animals, let's say dogs and cats, that's it, you're capped. Unless you retrain it, you add labels and all of that. So in that sense, when you train a language model next to an image model, we decouple the classification from the vision features. So basically, the image encoder understands vision, and the text encoder and the text decoder are general enough to kind of classify whatever you want. So it extends the interface of any visual encoder. That's an interesting point. I'm sure if you have any questions that feel free to ask. I can rephrase that again. Okay, I'll continue. And I have a script. It's called Hello World.py. I don't have enough time to run it, but I'll add it. You can run it and use browser use within your own computer. You can see all the information here. O4 mini is it uses by default O4 mini, which is multimodal. So basically it understands vision. It has inputs of vision and text, images and text. But you can also run it with GPT-4o mini by using only the DOM. And if you would do that, you would get these results. So I'm jumping to the final stages because we need to cover MCP as well. So by using text only the information in the DOM, we get fairly low accuracy based on the benchmark of we're talking about Visual Web Arena. So I just want to already give you the point is using text only doesn't really raise the accuracy. Text only plus captions, kind of better. Captions are descriptions of the images if there were any images in it. Multimodal, better, still fairly low. And some currently is the state of art. What is some? These are not updated. This is somewhat old results. Some is this representation. So here's the original web page. You can see that around all of the visual sections, they're numbered. So you can see that the screenshot contains them, and also the DOM itself, we're adding the numbers. So we're giving this representation, we're simplifying to the vision language model, we're simplifying the input, transforming it to something much more understandable. Like, look, this is this component, this is that component, and that helps. I love this kind of innovations, which are, it's not a breakthrough again in some algorithmic, it's understanding how to change the input in a more understandable way. So it's a cool trick. I love it. Okay, back to here. So I kind of saved the actions that my browser agent decided. My goal was compare the price of GPT-4o and DeepSeek V3. So you can see the next goal I decided was to locate visual cost information. Then it was stuck for a few actions in CAPTCHA, like prove you're not a human. After it tried to do it a few times, it changed strategy to find a different website. So that is the chaotic environment of websites. And it decided dynamically, okay, I'm stuck, let's go to somewhere else. Cheeky. As I've promised, screenshots are better viewed if they're indexed by their components of the DOM. You see it in browser use. It kind of captures the screen, and it's always with these bounded boxes. I found the system prompt of this open source thingy. So you can just have a view, see what kind of instruction do you get. It's interesting to kind of see open source solutions. It sets the default working language. At every step, your input will consist, so the system prompt explains the input as always. Each step, you have an evaluation and assessment of the last action, memory of this step, and next goal, and so forth. This is really interesting. Here are examples of good outputs and so forth. I encourage you to look at it afterwards. Here's some code. AI invoke, that reminds me of something, and you can see that it supports different models. So this is again model agnostic. AI invoke is a similar syntax to LangChain. So what was the design philosophy of browser use? Basically, oh wait, I didn't go over the code. Yes, you need to view the code for a second. Just a second. It's quite simple. That's it. So you can programmatically define, oh no, temperature 1.0. That's bad. So you can programmatically try lots of different interesting things. And all of the examples, of course, will be included in the classroom, so you can go over it. Okay. It is LLM agnostic, as I showed you. You need only a few lines of code to start working. It is not bounded to screenshot vision, but you probably need to use it. Oh, wait, what? Your screen sharing is paused? Okay, now it's okay. What are browser agent challenges? So sometimes the goals in the planner stage produces are kind of vague and can be interpreted in different ways. There might be a lot of blue buttons. So some of the improvements can be made on the specificity of the goals. There's a lot of challenges around the dynamic and unstructured content. Because websites have complex behaviors of JavaScript, the agent might be viewing something that is not fully loaded and have some missing information in it. And lots of authentication issues, whether it's cookies, captchas, 2FAs, all of this are probably blocking a lot of agents. Agents can land also on error pages and kind of stuck there for a while. And it's the fifth issue, the hard to validate success. I think that's the most profound one. Because sometimes it's not really clear if the agent is done or not. And that's really hard to stop that loop. For instance, if you got to a page, you had to, let's say, summarize something, and you've opened the page, but it only had a title of the whatever you're trying to summarize, and the rest of the summary is in a different link. So the agent needs to understand that the information it has is somewhat limited. It needs to choose to go to the next link as well. It's might be obvious to a human, even to a human, sometimes it's not. Like sometimes I need to really understand what I'm looking for and what I really need to do. So there are a lot of examples that you can think of defining success is kind of vague. So in that case, that poses a real challenge for an agent. Then it can spend like much, like the practical implication of that is spending lots of money or in compute or not achieving the goal properly. There are lots of different and interesting data sets and benchmarks. I won't go into them. You can read later the notes and uh, just as like a visual example of the MMU that is interesting. So there are different tasks under the MMU benchmark, art and design, business. There are lots of um, like diagrams and graphs. So visual tasks are very, very interesting. There are different visual tasks, as you can see. There can be more inclined to math. They can be in different domains totally, like music. Among the following harmonic intervals, which one is constructed incorrectly? That's a great domain for an LLM to expand into. And here's the leaderboard. So humans are still like overall better than machines on this task. But I have to say, like MMU is a static benchmark, which is does not contain the complexity of trying to find dynamic things and the complex decisions. This is more on the logical side of visual information. And I already shown you Surfer H that doesn't use any DOM at all, DOM information. And here's an example of a pretty visual data set. We have a description of something to click on and the correct coordinates. So basically, the visual component needs to decide what to do with this information, and we have a very good ground truth to test upon. This is much more easier to validate, for instance. And I've added an example of computer usage agents as well. There's a LangChain example of with Scrapy which I love the name. Scrapy Linux machines, like they work in this VM environment, and you can see the actions that are exposed to the agent. I found it in the source code. So these are the things that the agent can choose. So basically, it mimics the keyboard. Not surprising. To summarize, we add scripts, they're brittle. Browser user is greatly enhanced by vision language models. Clip is a method to train VLMs. Most VLMs use DOM plus screenshot as input. Browser tasks are highly multi-step. There are lots of evaluation tasks. One of the ways for me to understand a new domain is going through the benchmarks and evaluation tasks. It really helps me figure out like what is the kind of input and output that is valuable to judge. So I really, really recommend going over evaluation. And we've seen one innovation throughout the following year is the set of marks, adding to the screenshots the visual information of tying DOM components to the actual screenshot. And there are new waves of LLMs that actually don't use the DOM. Great. For the following 15 minutes, we'll just cover the basics of MCP. If you have enough juice left, I've saved it for last because I believe these are the things that are somewhat easily covered through other resources, but still, there are lots of misunderstandings about MCP, and I'll go straight to them. So, what it is, Model Context Protocol. One can say that basically MCP is a very shiny thing, which behind this is just REST API, good old backend API. You can achieve most things by just explaining, by having some REST URL, explaining its inputs and outputs to an LLM and giving it as a tool. That's it, just like a REST API client. So a lot of it is really, a lot of the hype around MCP is kind of just hype oriented, I think, but it is exciting. So let's see why. So we had our homework with Bytex dataset. Imagine that you don't have a data frame no more. You only have backend calls. And what are the backend calls that are exposed? Get category messages, get intent messages, and get the mapping between IDs and the string names. And so instead of having the data frame and filter it, now your agent basically needs to figure out when to call which backend. Like what resource is more applicable to this. But as if it was that simple, in most APIs, there are tons of methods. So it's not like I can um, auto create and tell the LLM about all of the APIs. That's a burden. That's too much information. So there's an API dilemma. As a server developer, what kind of APIs I want to expose to my LLMs, to any LLM that will try to consume it? And as a client and host developer, I need to first figure out which servers exist, and out of those servers, what is more applicable to maybe my tasks, my LLM tasks. So MCP tries to kind of help on both fronts. To the client host, we want to figure out which servers are interesting and which API calls are relevant, and how to explain what the API returns and what are the arguments are. And for the server, um, again, very similar angles. So for that, we have MCP. To clarify, there's a host. Like in general, server client architectures, there is a client and server, just as I've mentioned. With MCP, there's a host as well. The host can be any program. It can be Claude desktop. It can be a command line Python tool. It can be Cursor. What the host does is it connects to whatever servers it wants, and the servers have, like the host creates the clients per each server. So there's a relation one-to-one with the client with the server. Each server basically exposes, let's say, tools that the client can use, and then the host, given some query, can choose whatever tools it wants from all of the assortment of the clients it has. I'll have an example. So to simplify, we have a host, we have different clients, we have different servers. Each client server are one-to-one. So why is it like how can one use it, let's say, with OpenAI or Claude? So I can define that I want to have stock exchange information as MCP server. That server can expose tools like get most recent stocks that are up or most recent stocks that are down. Once I configure that to my Claude desktop or OpenAI ChatGPT, whenever I'll ask, hopefully, something around stocks, it will trigger server, that server client, and it will give me the most recent stocks that are up or down. So in this way, I can give to my Claude or OpenAI or my command line like hundreds of MCP servers to try and use throughout my work. So it can be general. Claude and OpenAI are general tools, but it can be much more specific. Let's say I'm writing a tool for myself, um, and I want to consume Jira tickets from my command line. So I can write a tool in Python that connects a client to a Jira host, for instance. And there's one tool that is called get tickets. And whenever I'll converse with my command line tool, say give me tickets, it will just run that thing. I could have accomplished the same thing by actually triggering the API request that's going on behind the scenes. So API calls and MCP are very, very analogous. Just MCP kind of reduces some friction of understanding which API calls are more relevant for LLM tasks. As sort of analogy, you can think of MCP like a USB-C port for AI applications. The actual standard USB-C doesn't care what it's being connected to. It's just an interface to enable connections. Here's a server example. See how am I on time? I'm good. So I'm defining very, very simple MCP server. This code will work. You can just run it. What's something that I do need to mention is that I'm running it with transport stdio. So servers can be run in two different ways. There can be run on like reactively, I can say. It can be triggered as we want to connect to them. Just an instant. It's like it's not listening to any port. There's not a real server there. It's just some script that can be triggered on a request. And then here's the client. It's working asynchronously. This won't run. This actual example won't run. You need to add an async def to this and create a main. The file that I'll upload to the classroom does contain it fully. So don't be afraid if it crashes. Just need to add this async definition to it. So what does the client does? Actually, it's a host. So it's a host and a client. And here is the client part. I define what server I want to connect to. So for this example, because it's a reactive server, as I call it, I just need to define the path to the script. What will actually happen is if I'm creating an agent here. These examples, by the way, are bootstrapped by LangChain. It really helped me show you an example without any small details that are irrelevant. So in this case, I really love the LangChain abstractions. So I define a server here. I'm defining a client session. And then I'm loading the MCP tools. Basically, in order to load it, I need to launch my server. And it's launched as immediately. And then I create my agent. And I invoke a real message. What's 3 plus 5 times 12? So just to remind you, it's a calculator. So it uses the tools and answers. It invokes basically these tools. Now, these tools weren't in my code base. That's pretty cool. So we have the ability now to run tools that were defined as somewhere else and use them as well. So that is an exciting thing. And I have to stress that again, we could have defined the tools ourselves and then call some API backend to act upon them. Here's a multi-client server example. So I'm defining, it's not the full code. The full code is in multi-client server.py. And I'm defining two servers here, and I'm getting the tools. And then whenever I run, the client, the host will choose which client it wants to run based on its connection of the query to the tools it has. So we can connect many tools, as you can see. I'm not changing the code, I'm only attaching different configurations of servers. So that's very extensible. This server, the weather server, is a little bit different. As you can see, I have a URL link here. It's basically, it's a backend server that runs. It has MCP definitions. Wait, I'll show it to you. Yes. Here's the weather server. It's not that big on code, but basically we are using the MCP library in order to define an MCP server. And this thing has to run. So basically, if you're not running this script, it won't be able to work. But this thing is totally reactive. You don't need to run this. It's not listening any port because its transport is stdio. And this is not really, like, you can run it, but you don't have to run it. Okay, back to here. So just a summary. The host chooses. Did I get any question? No. The host chooses which service to use. The clients know how to run them. The servers themselves define which tools are relevant for clients. And host can choose the servers that they're the host configure which servers to operate. Once all clients are connected, we can start invoking different requests. As I mentioned, there are two server launch options. There's the stdio. Basically, the server will be forked as needed. It's just something that happens when you load the host. So there's no real backend here. It can be operated by Docker as well. There are lots of different options here. Please go and view the links. Just a second. I think it will take a few more minutes of your time. Oh wait, why is it paused? Okay. And then there's also real like backend like servers. There are lists of exposed servers that you can run in either configuration. So there are tons of servers that don't need to be really that can be just installed locally and you can use them. Even though if you are installing locally, it doesn't mean they don't need certain API key. So just look at Google Maps example. It expects an API key. So it will do calls on your behalf. It won't work without an API key. But others are totally local and working with Docker. I think Puppeteer is like that. Yes, there's a Docker container version and also there's an NPX version. NPX is running an NPM, let's say node code running a node library without installing it. So you're just running it on demand. Just like UVX, if you've tried it. Okay. There are additional server definitions. The servers can expose not only tools, but also resources and props. I don't want to go over it, but basically just imagine that you can trigger complex workflows that were exposed by the server. So a tool is maybe a single thing that's happening, but you can also run full prompts and full workflows. That opens up to a lot of exciting things as well. And actually, to be more it's not the LLM actually operating the prompts, it is user controlled. I hope I didn't confuse it too much. But basically, they expose to the host different options that you can try and work on. So, for instance, slash commands, so things that were pre-configured. Most of MCP can be achieved with API calls. I already told you that, but MCP makes it easier. It's not only that, it's not only the easier part, they also say that you don't need to change your code. That's very strong. Basically, you're configuring different servers and you're gaining capability on code that you didn't write, which is exciting and scary. And that's the limitation. Well, there are a lot of issues with authentication. The MCP spec didn't include authentication at first, then it did. It's still work in progress. There's security risk. There's a huge security risks. You are running things basically locally at the end of the day. Some of the things let's say you're using a tool to consume like Google Drive documents. And top of that, there'll be some question to the LLM. The document that have been chosen, it was chosen by the LLM. So it's kind of scary of the things that might be included in some of the requests. And it's something to really think through. So I wouldn't advise running an MCP and working with it unless you understand all the little details from the start to the end. So there are lots of prompted injections that can happen. Things can load that contain like hidden prompts with different instructions. It can be a mess. It is a mess. So be wary of the implications. API endpoint, to summarize, API endpoints are not MCP, but it's a pretty close analogy. Any app can be an MCP host. A single host can have many client-server connections. MCP adds functionality without the need to change the host's code, which is pretty cool and scary. And in order to disallow malicious behavior, please make sure you understand all the things that happen throughout. Great. I think we finished with most of the things. I just want to go over the classroom information. Okay. I just want to make sure that everybody understands the context of the next homework. So we need to re-implement our previous assignment, the data analyst, with LangGraph. So whatever, you can stay close to whatever you had before, or you can re-implement it differently. It's up to you. My personal recommendation is creating two separate agents. One can have different tools. It's up to you. And then we need to implement follow-up questions, follow-up queries, the chance to ask additional questions. If you already did it, great. If not, now is the opportunity. But there's a caveat, you need to implement it with LangGraph machinery. Just to get visibility in what that means, you need to run the agent memory notebook from the class materials. You'll see there like an example of how to do it. Then we have an exciting new avenue, the memory function. So we want to enable agents to remember key information about the user. For instance, if somebody is asking on certain categories or intents, we might want to save that because it can be very useful to derive like the actual use case of that person or to understand its preferences and then to improve the whole experience. So you can implement the new capability like summarize node, and you can test it with queries of what do you remember about me. So actually there's another addition to this. We need to change the router to start routing to this part as well. And then the bonus assignment is next query recommender. So based on the things that happened so far and my memory of you, what should be the next query? Here's an example. Think it through. It's very interesting and exciting task. It becomes quite similar to what happens in mature conversational AI products in a way. So you have a simulation of what kind of feature exists and a hint on how to achieve them. Okay, some notes. We are going to attempt different attempts per test query. Make sure to test it several times and not only once. The focus is on learning, not efficiency, so you don't have to optimize the code to be super performant. That's not the point. Reuse and implement the tools in assignment 1. You need to stick to still be within the same framework that we worked before. You do have the option to change the implementation, but it still needs to be functioning data analysts. Please include a README with setup instruction, including the required Python version, requirement.txt or project toml for dependencies. Please do not submit Jupyter notebooks, just Python code, preferred with a Streamlit. You can integrate Langsmith. I didn't show exact instructions on how to do it, but it's pretty easy to do. You just need an API key and that's it. Langsmith will give you an option to observe all of the communication with the LLM. Its input, its outputs, everything. And please go again through the example notebooks if you feel like stuck. One final thing. I'm broadcasted to the YouTube channel, but I have been with I've known you throughout the course and throughout the last course on data science in production. So I wanted to have a chance to thank you and to say that it's a journey. You're in a journey, and just to summarize a little bit of the things that we went through the course, agents are, I'll start with the most like risk adverse thing. Agents are risky. Freedom is risk in a way. So choose workflows over agents when possible. And if you don't have to use AI for whatever you're doing, don't use it. You know, more freedom is sometimes adds difficulties that you don't have to. It's all about planning. That's the main thing. That's what drives complex tasks and complex objectives. We talked about planning, that it can be pre-planned, an exhaustive plan without any leeway to do something different, or it can be reactive and like being in a replanning stage. And that's the most basic React agent example. It's all about tool composition. you need to figure out between expressiveness and simplicity. So you can implement data analysts by having 4 or 5 tools that can run queries without actually the agent writing any SQL, or you can give it the option to write SQL as much as it wants, or even writing code to achieve something. Those degrees of freedom is what makes something easier to debug on the one hand, but reduces expressiveness, or on the other hand, very hard to evaluate, very hard to debug, but very expressive. And the expressiveness is counted as the amount of tasks that you can actually complete. So the more freedom you have, the more freedom the agent has, it can achieve more in a way, but it comes at a cost. It's all about patterns, recognizing patterns, whether it's a feedback, critique, RAG, agentic RAG. The patterns are kind of repeating themselves. So one of the challenges in our domain is to take a pattern that you've seen in a totally different use case and to understand that it's very similar to your current use case. And it's all about being curious. There's no magic. Well, unless you want to believe in magic, but there's no magic in code. It's everything that runs with some code, and you can find it. You probably can read it, unless it's closed source, of course. But then you can find something open source that might be similar to that. So if you think it's magic, if it looks scary, then you kind of owe yourself to find out the trick behind it. Of course, if you want to challenge yourself. You can always find me on LinkedIn, on Discord, on different channels. I have channels called Hacking AI. And from time to time, I'm uploading videos there. You can find a lot of material on DSPY there, by the way. I'm doing a lot of side quests, like I'm implementing lots of things that are interesting me. You can join me. I'm always free to collaboration. Don't be a stranger. Update me, whatever your like you have a questions and things like that. And a final message: the most important thing is the human in the equation. Why? Because we have the values, we decide what to build, and sometimes we actually decide how to build it. Don't delegate your personality. Basically, you are what you are because of your experiences, and that is the most valuable thing. It's not a technology, it's you. That's my message to humanity. Thank you, everyone, and be in touch.
Thank you very much, Serj, for the course and for this lecture. And we'll be in touch.
Bye, everyone.
Do you want to? Let's see. No, we don't have open questions. So, bye-bye, everyone.
Thanks, Carmel. Thanks, Serj.
תודה
Bye.
רבה, סרג'.
Bye, it was a pleasure.
Thank you. Thank
שמור
you.
על קשר.
Thank you. Bye-bye.